All right, so we are starting week 2 of graphing, and we are going to look a little further into how to graph quadratic equations, their key features, and properties that you find. So we're going to start with an activity that I'm going to start you on, and that I want you to go through and actually finish on your own. It should only take you a few minutes. If you have access to a printer, I highly recommend that you have this sheet of paper printed for you. If not, go ahead and create a quick chart on a sheet of paper or in your notebook. But again, if you have access, having this printed will make your life a little bit easier. So before we actually go into the activity, I want to make sure that we understand everything on the chart. We have different equations. We're going to identify our vertex, whether or not we have a maximum and minimum value. This line of symmetry is also known as your axis of symmetry. So that's what we referred to it in the last lesson, the axis of symmetry. We have our range. And then we're going to compare our new graphs to our parent function, y equals x squared. And we're going to describe the translation. So if you remember from IM1, a translation is whether your graph shifts in any way. So it can shift up, down, left, or right. So we're going to talk about what kind of translation or shifts we see. There's going to be another type of translation that's going to happen as well, but we're going to see a lot of movement. And then how does our shape change? So our shape is whether we have a compression or a stretch. If there is no compression or a stretch, then it's just going to be our parent function, okay? So there will be no change to that. Now remember, compressions and stretches happen based off of your A value. So if your A value is between 0 and 1, you have a compression. It gets wider. If your A value is greater than 1, it's going to be a stretch and it's going to get skinnier. Okay, so what I need you to do is go to Desmos.com. And I've already done that, but okay, we're going to go to Desmos.com, and this is the screen that you should see, and you're going to click Start Graphing. The really cool thing about Desmos is it helps you identify whether you're doing things correctly. It helps you check your work. We will also be doing a project at the end of the semester where you will use Desmos, so it's important that you know how to use it. Okay, so everyone should be on this screen. And we're going to start by typing in our parent function. So if you notice in the very first row, as they fill in the boxes, it says parent and it says y equals x squared. So I'm going to type in y equals x. Now on this bottom corner, I have a keyboard. If you click on that, it gives you your squared button. And there is my parent function. So that's what we graphed in last week's units. Here it is for you. Now we're going to keep that on our screen the whole time because we want to be able to compare our parent function to each of the new functions that we're looking at. So in the next row, and I'm going to just flip back over real quick, our next row is x squared minus 3. So let's look at what happens when we graph x squared minus 3. Okay, so I clicked down below and I'm going to type in y equals x squared minus 3. Okay, so my original parent function is the red function. My new function is the blue one. And I'm going to identify some features. I'm going to zoom out just a tad so I can see everything. So if you use your mouse and scroll over, remember your vertex is that high or low point. In this case, it's our low point. And if you scroll over it, it tells you what the vertex is. So our vertex here is 0, -3. Okay, the vertex is 0, -3. Because we have a low point, right? We start at the bottom and our graph increases. Then we have a minimum value. Our axis of symmetry is always x equals, and it's going to be x equals whatever the x value of the vertex is. So in this case, the x value of the vertex is 0. So I have x equals 0 as my axis of symmetry. My range, I start at my vertex and it's a low point and everything increases. So it's y is greater than or equal to. But what is the y value of the vertex now? So I'm going to come back to this screen real quick. So if y is greater than or equal to, but the slowest point that vertex goes is -3. So y is greater than or equal to -3. Should be your range. The next part, compared to y equals x squared, describe the translation. So what happened? How did this graph move? Right? So it started here at 0, 0, and now my vertex is down here. So what happened is that I shifted down 3. So my graph went down 3. Okay. Now I also want to know if there is a change in shape, a compression or a stretch. Now remember, if A is between 0 and 1, it's a compression. If A is greater than 1, it's a stretch. So if you look at your equation, it's really x squared, so it's a 1x squared, right? Right here, so it's a 1x squared. So there's not going to be any change to the actual shape of my graph, and I'm going to show you why on here as well. So if you look, it looks like it's the same. Now if I took away this -3, right, that shifted down, now it's exactly the same as the other graph. So the only difference is that -3 shifts my graph down. Okay, so let's choose another one from that. Let's go down to 5/3 x squared plus 2. So we're going to do that one together. So I'm going to delete this blue one. I'm going to keep my parent function because I want to be able to look at that. And I'm going to type in the next one. So y equals 5/3. Now to type in 5/3, you're literally going to do 5, a slash, and it makes a fraction sign, and then 3. So 5/3. Now I'm going to have to move my arrow over, right? Because if it's part of the fraction, it's going to mess up. So you want to make sure you move it over. And it's going to be x squared plus 2. So 5/3 x squared plus 2. So my new graph is this green one, right? The parent function is in red still. My new graph is green. So the vertex of my new function is 0, 2. Okay, you can scroll right over it to see. Again, I have a point that now is at the bottom, and my graph increases from there, so I have a minimum. Our axis of symmetry is x equals. It's always going to be x equals, and then it's the x value of your vertex. So the x value of my vertex is 0. And for my range, I have a low point, and it increases. So I'm going to come back over here real quick. So I have a low point, right? I have a minimum, and it increases. So its y is greater than or equal to, and it's going to be the lowest point, which is 2. It's the y value of your vertex. So y is greater than or equal to 2. So let's actually look at the translation, what happened here. So we'll notice that here was my initial vertex, and my graph now went up 2 units, right? It shifted up 2. My graph shifted up 2. Now, is there a change in shape? Do I have a compression or a stretch? So if I look at that and I were to take away this +2, right? Because really that's all that's changing, that +2. Is my graph skinnier or wider than my original graph, right? Hopefully you notice that it's a skinnier graph, which means I have a stretch. It got skinnier. So you have a stretch for that graph. Now that should make sense to you. Is 5/3 greater than 1, right? It's 1 2/3. And anything greater than 1 gives us a stretch. So in a second, you're going to go back through and you're going to fill in those other 4 rows. But let's look at this bottom part. Okay, so our equation changes a little bit, but I still compare it to the initial parent function. All of the information here is the same. So let's start with, why don't we do, well, let's just do the first one. Y equals x minus 2 squared. Okay, so I'm going to come back over here and get rid of that equation and type in y equals, and then parentheses, x minus 2 squared. Okay. Now let's see what happens here. So first of all, let's find our vertex. And again, you can scroll over that point and your vertex is at 2, 0. We have a low point, everything increases, so I still have a minimum. My axis of symmetry, x equals, so start with that. And it's going to be the x value of your vertex. In this case, the x value of my vertex is 2. My range, I have a low point, so it starts low and increases, so y is greater than or equal to. Come back over here for a second. Okay, so y is greater than or equal to, because it's a minimum, it increases. My graph faces up, and it's the y value of your vertex, which is 0. So y is greater than or equal to 0. So let's figure out what actually happened. How did our graph translate? So I started here at 0, 0, and in this case, my graph moved to the right. So it shifted to the right 2. My graph shifted to the right 2. Is there any shape change? Does it look like that would be if it shifted back to the left 2 and was on 0, 0? Does that look like those graphs would be on top of each other, would be exactly the same? Hopefully you're saying yes. You'll also notice that there's no value out front. And so if there's no value, there's a 1. And if there's a 1, there is no change to your shape. Okay, so here is what that row should look like. We're going to do one more. We're going to pop on down to y equals negative x minus 1 squared. So I'm going to get rid of that. I'm going to go y equals negative x minus 1 squared. Oh, this changes a little bit, right? So let's see what happens here. Again, scroll over to find your vertex. And my vertex is at 1, 0. Now, I have my vertex and all of my values are now decreasing. So I have a high point and they decrease. I'm at a maximum point. Nothing will get higher. That's my highest point. My line of symmetry or my axis of symmetry goes through the vertex, and I'm actually going to come back to my paper to point to things. It's always going to be x equals, and it's always the x value of your vertex. So the x value of my vertex is 1. It goes through that point vertically at x equals 1. Now, because I have a maximum, right, I have a high point and everything else decreases. So it's y is less than or equal to, and it's going to be the y value of my vertex, which is 0. Now, what actually happened? What translation occurred? Let's see. So for the translation, I still shifted to the right 1. So I shifted right 1, and I'm now upside down, right? My graph flipped upside down. So I shifted and I flipped. Now, is there any change to the graph? What if this was positive? Okay, so I'm just going to take away the negative so you can see what happens. Does that look like if it shifted back over to 0, 0, they'd be right on top of each other? Hopefully you see that. Plus, this value here is a 1, right? That didn't change anything. So that 1 tells us there is no change to the graph. Okay, so you're going to take the time, it should only take you a few moments to go through each of these. So you're going to want to type in each one and fill in the columns. Some are going to shift left and right, some will shift up and down, and then you'll have to determine what kind of change happened in each of those graphs. Now you want to make sure you complete this before you move on to the notes, because this is kind of the foundation of today's notes.